Okay, here's another example. I have to find this limit. X approaches infinity. So now, normally, as we did before, the highest power, this is a rational function. The highest power in the numerator is 2. The highest power in the denominator is 2. So I would divide numerator and denominator by x squared. It's like I did in the last couple examples. And that eventually get me the answer, but there's a faster way to do these rational function problems. You're finding limits at infinity, and that is, notice the degrees. We have 3 cases here. Degree of, well, okay, the way I've got it here, n is the degree in the numerator, and m is for the denominator. If the numerator's degree is bigger, then the limit won't exist. If the numerator's degree is less, then the limit is 0. If the numerator's degree is the same, then the limit will be the quotient of the leading coefficients of the numerator and denominator. Okay, so notice in this case, I have case 3. My answer should be 3 over negative 4. Because of those are considered the leading terms, 3x squared in the numerator and negative 4x squared in the denominator. So my quotient, the limit of this quotient should be 3 over negative 4. That's according to these results up here. We can use these general results. We don't have to go through all the effort of analytically determining this. We use these results. It'll save us a little time. Okay, so you're welcome to use those. Let's look at the next one. Okay, now here, these are not rational functions. So you can't use what we just did. You have to try something else. So immediately, I'm going to notice that with a direct substitution, I'm getting infinity over infinity. So what I do is I'm going to do something like I did in the last problem, but I have to determine what to divide by. So I look at it like this. I look at the numerator or the denominator and I say, when x is very large, that minus 4 doesn't really amount to much. So I really kind of just have the square root. In other words, this part over here is really not, it's negligible compared to this part here. So I really have x over root x squared, which is the same as x over x. That's like a 1. So I'm suspecting that this thing's going to behave like a 1 as x gets really large. In other words, my limit would be a 1. This one is the same kind of thing, except that the numerator is heading to negative infinity, and of course the denominator is heading to positive infinity. But using the same logic with removing this, I would end up with a negative 1 in this case. So I suspect that's going to happen for these. Now, if you wanted to take it down and look at a little bit more detail, what you'll do is this. You'll divide by an x like that. And down here, we'll come in here and divide by, we'll put an x squared in there. Now, since x is positive, I can exchange the x for the square root of x squared for x positive. Okay, so that's no problem. So I've divided numerator and denominator by an x. That leaves me with this, 1 over square root of 1 minus 4 over x squared. Now, this term in here has 0, so I end up with a 1 over root 1, which is a 1, as we kind of suspected. Now, the second problem, you do the same sort of thing. You're going to divide by an x, but down here, when you put that value in as an x squared, you've just changed a negative number into a positive in that denominator. In other words, when x is less than 0, then this is actually equal to the negative of this. Okay, it has to be. So in the denominator, I've actually included a negative number. So I'm going to make this negative. Okay, so that became a negative down there. And then this becomes, now let's let's write this as 1, and I'll move that negative up there. And this down here is 1 minus 4 over x squared under the radical. And again, as x goes to infinity, this goes to 0, end up with negative 1 over root 1, which is negative 1. So I have two asymptotes for this guy. This function has two asymptotes. One of them is at 1, another one is at y equals negative 1. So I have two asymptotes depending on if you're heading down to infinity or negative infinity for the x values. So that's an interesting situation. That can happen with these radical functions. You got to be careful with the radicals.